In the Middle Ages, alchemists pursued a seemingly impossible dream to transform ordinary lead into the symbol of a bright, shining future. While it may seem a bit naive to us today, they dedicated their lives to this idea. While history books often portray them as strange, obsessive old men, they didn't know something. Their dream wasn't so impossible after all. Yes, today's gold can actually be produced in dark laboratories, but it's hidden much further away. So how did the elaborate story of gold begin? Did it emerge dissolved in rocks like oil? The truth is a bit more complex than that. Gold doesn't even belong to Earth. It was born and reached Earth from the depths of space billions of years ago. Just think, good things called jewelry are actually the last memories we have of the universe's most violent explosions. But how is it that this path, which begins inside a star, extends to a tiny surface on our fingers? Now come with me and let's discover the incredible story of gold descending from space to Earth. To process the gold data, we first need to separate the nature of stars, because everything begins with hydrogen, the most fundamental building block of the universe, where the components of a star are located. In young stars, almost all of the components are composed of hydrogen. Indeed, it is the initial fuel of the mixture inward, despite being the simplest and lightest element in the universe. Temperature and pressure reach unimaginable levels. This is when an extraordinary process begins: nuclear fusion. In simple terms, nuclear fusion is the process where atoms merge. Normally, atomic nuclei repel each other, but under these extremes. But nothing lasts forever. Over time, stars age. Conditions when hydrogen in the core runs out, helium, hydrogen nuclei fuse into helium fusion, releasing tremendous energy that allows the star to shine burns the universe. Carbon, oxygen, and progressively heavier elements every second. Billions of hydrogen atoms are converted into the formation of the next, continuing the chain. A star operates like a cosmic furnace, producing heavier and more complex elements at every stage. Here's the interesting part. Each new fuel burns faster than the previous one. The star's lifetime becomes a rapidly accelerating countdown, and when it reaches iron, the spectacular process suddenly stops. This is the end of the line for the star, because producing iron doesn't release energy like other elements. It consumes it. The star can no longer generate power in its core. At this critical moment, the core cannot support its own weight. The outer layers collapse rapidly inward, then violently rebound outward, creating one of the most powerful events in the universe: a supernova. Now let's turn to the asteroid belt. Astronomers believe some asteroids may contain more gold than all the reserves on Earth combined. Imagine, one day, when we reach these rocks, gold might no longer be considered rare. Perhaps gold jewelry will become nothing more than nostalgic keepsakes. And imagine even further: massive mining ships drifting through space, robotic arms gripping asteroids, lasers cutting into rocks. The gold hunters of the future may wear long spacesuits instead of cowboy hats. Humanity's new gold rush will take place not on Earth, but among the stars. When we reach these rocks, gold might no longer be considered rare. Perhaps gold jewelry will become nothing more than nostalgic keepsakes. And imagine even further: massive mining ships drifting through space, robotic arms gripping asteroids, lasers cutting into rocks. The gold hunters of the future may wear long spacesuits instead of cowboy hats. Humanity's new gold rush will take place not on Earth, but among the stars. If you've watched this video all the way to the end and learned something new, you should know that your support for my newly created channel truly means a lot. Don't forget to like, subscribe, and leave a comment. Your support allows me to keep creating more content. Thank you for watching, and see you on the next Journey Heart.